Hey everyone, and welcome to CircuitMess. In this video I'm going to tell you about the role of 3D printers in the process of developing the CircuitMess's products. So the main two parts that every single one of our products has is the electronic circuit board and the casing, usually being the plastic parts. After we design the circuit board, we have two main ways of designing and manufacturing the casing of the electronic product. Some of the electronic pieces, some of the plastic pieces are cut using a CNC laser cutter. This is a machine that usually has two axes, so the X and the Y axis, and then you place big plastic sheets into the machine, and it uses a laser to cut out these plastic parts here. You will see that usually they are very nice looking like this. They have these very clean cut edges, but they usually can they can only be made in these very simple forms. So if you need some very complex geometry, like an example, you want to make a batten bill like this, then you cannot use this process of cutting these sheets on a laser cutter. If we want to do this, then we opt for this process called the injection molding. The injection molding is a process how basically all of the casings for the products that you usually use in your daily life have been made. So basically, let's take this one an example. This one was made using injection molding. You had like a steel mold, and then you had this special machine which heats up the plastic and injects the plastic into this mold, heats it, then cools it, and then this plastic part comes out. This is used when you need to create very complex geometry, such as this one here. But the first step of the process is to actually design this part that you're going to use in your product. We first take a computer like this, we design the 3D model for the part, but before sending it to the factory, we need to make sure that this part actually works, because a mold for a plastic part like this can range from like $1,000 to more than $10,000 for very big and very complex parts. These molds are actually very big and very complicated steel structures made by factories, and they usually take weeks to make. So instead of spending a few $1,000s on every single mistake that you do, we do this thing where we actually 3D print these pieces before we send them to the factory. For this, we use two main types of 3D printers. We have this one, which is actually called the FDM printer, which stands for diffuse deposition method. And we have this one, which is called the SLA printer, which stands for stereo lithography. The main difference between these two is that this one is, let's say, less expensive, and this one is more expensive and more precise. This 3D printer, it uses this reel with this tiny filament here. This filament is thermoreactive, which means that it basically melts on a specific temperature, and then this filament is put into this thing here, which is called the extruder. The extruder, it heats up to a certain temperature, it melts the filament, and then it takes this very tiny nozzle here to make different layers of a model that you are 3D printing. You can see this on this plastic piece here. You will actually see lots of these tiny lines or layers. This is because this 3D printer is actually making these layers with this tiny nozzle and basically building on top of each layer like this. This is good if you want some hobby parts and if you want to make something that's not going to be as precise. But if you need to make something very complex and very precise like this one, then you need to use a more complex 3D printer which uses stereo lithography. This one is my favorite, and I'll explain to you how the process works. So this is actually very exciting, and it's one of the oldest methods for 3D printing that was invented in the 1980s. It basically uses this colored goo here, which is called the resin. this resin is standing in this tiny bathtub here, and then the device has this big screen on the bottom which emits special type of light that makes this photoreactive resin come together. By doing that, it's actually doing the same thing like the fused deposition method printer. It's printing these tiny layers, but it's doing it in a much more precise way. The part actually starts by, it sticks onto this platform here, and then the printer slowly submerges, makes a different layer, takes it out of the liquid and puts it back in again, and does that for a few hours until you actually make this part. And you can get very complex geometry by doing this. This is a sample of a part that was made on this printer, and you can see that it's very, very, complex. Lots of, very complex and very rounded elements here. Finally, after you make all of these prototypes, sometimes if you make something on a 3D printer, it needs to be adjusted for the actual factory. So let's take this part as an example. Because of the way these molds are made, we needed to split this model that we had for the Batmobile in several different parts. First, we wanted to have these parts here in a different color. So because of that, we have decided to exclude them from the model and make special separate molds for these so that we can make them out of a differently colored plastic. But then also this part here, we needed to make a different mold for it, and then it was glued to this place here. And this one at the back as well, we needed to take it and place it in a separate model. This is a process that you usually go through when you talk to a factory that does injection molding. They tell you what the limitations are for their setup, and sometimes, unfortunately, you have to comply with their regulations in order to make a very geometrically complex mold, come to life. I hope you found this interesting. Please let me know if you want to see more videos like this one. Thank you for supporting CircuitMess, and keep making. Bye-bye.